Hi everyone, welcome back to our series. Hope you are doing good. This is Mahesh. In this video, we will look into LeetCode problem number 1480, which is running sum of 1D array. Okay, let us look into the statement of the problem. So given an array nums, we define a running sum of an array as running sum of I equal to sum of numbers from 0 to number at index I. Okay, return the running sum of nums. So they have given few examples here, and if you see the constraints, the length of number ranges between 1 and 1000, and the number, any number in the nums array ranges between minus 10 raised to 6 to 10 raised to 6. With that, let us switch to the editor and try to understand this problem in detail. So basically, this problem is pretty much straightforward. So what they are saying is we need to compute the running sum. So what exactly is the running sum? Basically, if we are at any number, then we need to consider all its previous numbers and we need to sum up and we need to place that sum at that particular place. Okay, so since this is our given array, now our running sum array will be, so first number will be, there is nothing before 1, so it will be only 1. So for second number, it will, there is previous number which is 1, so we need to add that with that particular number. So this is our second number. For third number, it should be 1 plus 2 plus 3. And for fourth number, it will be 1 plus 2 plus 3 plus 4. So this we need to compute. So this becomes 1, 3, 6, 10. So we need to return this particular array. Hope this is pretty much straightforward. With that, we have also seen the constraints. Maybe what you can do, you can pause the video, you can think for possible solution, and then you can come back and continue watching this video. With that, let us try to understand the brute force solution for this problem. So it is pretty much straightforward, right? I mean, at this particular index, since it is the first number, there is nothing before this number, right? So we will only consider this number. But if we want the running sum at this particular index, then we will have to consider all the numbers before it. Correct, right? Then for this third number, again, all the numbers before it. So how we do normally? So I will put a pointer somewhere. So if I want running sum at this particular point, then I will put a pointer, then I'll iterate from 0 till this number. So basically this is a 0 based indexing, right? So I will start from the value at 0th index, then I will iterate over until that particular number, then I will sum all the values. So likewise, we can compute all the running sums at all the positions. Okay, so now let us look into the pseudocode basically. So what exactly we need? First, we need one loop which iterates over the different positions to find that particular running sum. Then another loop to iterate from 0 till that particular number. Correct, right? So I will say, first I will say running sum. This is an array of size n. Okay, so this n is nothing but our nums size. So n equal to nums dot length. Okay, then I will use a for loop for I equal to 0 to n minus 1. Correct, right? First I will iterate over all the numbers. So there is no point in iterating from 0 to n minus 1 because first number anyhow there are no numbers before that. So what I will do, I will iterate from 1 to n minus 1. So here, once after creating this running sum array, what I will do, I will first push the first number to it. So basically this number, I will just add it to our running sum array. So I will do that something like this. Running sum of 0 equal to nums of 0. So this will transfer the first number as it is to the running sum array. Okay, then I will start from I equal to 1 to n minus 1. Okay, this is our first loop. Then I will take a variable sum equal to 0. This is to calculate the overall sum. Then I will take another loop j equal to 0. Now I will iterate until the value becomes equal to I, not n minus 1, because we want sum till that particular number only. So then what I will say, what I will do, I will sum up all the values from 0 to till I, correct, right? So I will say sum equal to sum plus nums of j, correct, right? So this will give us the sum. Then at the end, what I will do, I will say running sum of I equal to this particular sum. Okay. Then finally, I will return my running sum array. Okay. So basically what we did, one loop we used to place the sum value and another one to iterate from 0th index till that number to sum up the values. Okay. So now if you see what is the time complexity, our time complexity here will be of order n square. This is not exactly n square, but somewhere close to n square because we are using 2 for loops. Okay. So at the worst case, when we are trying to process the last number, it will iterate over the entire array. So since we process n numbers and for each number it is somewhat close to n, so it becomes order of n square. And if you see the space complexity, we use the extra array, right, to store the calculated values. So it is of order n. So this is the time complexity and space complexity for this brute force solution. Okay. Now, this is not a good solution. We want to improve it. So how to improve? Why? Because this takes O of n square, which is costly. So we want to improve this. How to improve that? So now in this particular case, what we did, so basically, if you see here, first number is 1, correct, right? So there is no issue in that. But if you see the second number, it is this previous sum plus that current number, correct, right? Then if you see the third number, this part is nothing but this previous number, then plus this number, correct? If you see the next number, it is, see, this is the previous number and just that particular number. So do we see any necessity to find sum from the start for all the values? No, right? So what we can do, we can use previously calculated value and we can simply add that number. So if you see here, we have got 6, right? If you see its previous sum, this is prefix sum. This is called prefix sum. Why? Because it is the previously calculated sum, right? I mean, till its previous index. That's why it is called prefix sum. So with this, in this problem, we are also trying to introduce the prefix sum concept so that it will be used for solving many other problems in the upcoming videos, which you will see later. So now if you see, this is the prefix sum. I am trying to calculate this particular running sum. This is the previous prefix sum. And if you see the number, it is 3. So if I add up this and this, we will get 6, correct, right? So now if you look into this particular value, it will be sum of this plus this number, correct, right? So that's what we will do now. So now what I will do, for the better solution, let us take the number array again, 1, 2, 3 and 4. Okay, I will take this as our prefix sum array. Okay, now 1 I will put it as it is. Then when I try to process this number, I will simply consider its prefix sum, which is 1. Then I'll add this with the current number. So what is the total? It will be 3, right? I'll place that here. Okay. Next, I will go to this number. Now, if you see what is the prefix sum, it is 3. Then what is the current number? It is 3. So now I will sum up those and I will place it here. Then I will move to next number. So now again, if you see the prefix sum is 6 and the current number is 4. If I add, I will get 10. I will place that here. Then once I move out, so I end up processing all the numbers in the array. So for this, let us look into the pseudocode. So what we need a prefix sum array, correct, right? So prefix sum array. So it is array of size n, correct, right? Then after that, first number we put it as it is because there is nothing before that. So what I will do, prefix sum of 0 equal to simply nums of 0, correct, right? Then after this, I will start processing from the first number for I equal to 1 till n minus 1. What I will do, I will simply say prefix sum of I equal to, so prefix sum of I minus 1 plus nums of I. This is what we did, correct, right? So we considered if this number, then we considered the prefix sum and that particular number, then we added both of them, then we placed that in prefix sum of I, correct, right? So with that, I will close this and I will simply return prefix sum array. So now if you see, we use only single for loop. So what is the time complexity now? So our time complexity will be of order n, correct, right? Because we are processing this entire array in single iteration. And what is the space complexity? It is again order n because we are trying to use this particular prefix sum array to store the values. That's why it is of order n. So with that, let us execute this and see. Let us take a variable int n equal to nums dot length. Okay. Now what we need an array which is prefix sum of size n, correct, right? So let's declare that. After that, let me copy this prefix sum. So the first value in this prefix sum will be the same value as in our nums array. Okay. Then after this, I will use a for loop where I starts from 1, I less than n, I plus plus. Then I will say prefix sum of I equal to prefix sum of I minus 1, then nums of I. Okay. So then at the end, I will simply return my prefix sum. Okay. With this, let me try to run it and see. So it got accepted and let me submit it. So it got submitted successfully. Now, is there any way to improvise this? So what exactly improvisation we can do? Time complexity is already O of n. So we are taking the optimal time. But if you see the space complexity, it is of order n. We are taking extra space to store the sum. Is it good solution? Yes, of course it is. But is there any better way to improvise this? Let us see. Now what we did, we took this prefix sum array, right? Now if I want to find the running sum at this particular point, we used the prefix sum, correct, right? Then we added that with this number, then we placed that here, correct, right? Did we use this for any reason in that case? No, right? So if that is the case, instead of storing this value here, why can't we store it here itself? We can do, right? Let us see how we can do. So now let us see. I have this 1, 2, 3 and 4. This is my array, correct, right? Now this one we don't touch because nothing is before that. Now if I want to get the running sum at this particular point, I will add previous number with this number because this is the prefix sum for this particular number, correct, right? Now what is the sum? 3, correct, right? Now what I will do, I will update this with 3. Okay. Why? We will see. Then I will go to next number. Now for this number, we want prefix sum. So which is already 3 here, correct, right? So I can simply add that with the previous number. So it becomes 6. Now I will update this value with 6, correct, right? Then for the next number again, for this one, it is this 4 plus its prefix sum, which is 6. So I will update this with 10. Then I stop processing. So this is pretty much straightforward, right? Why this was possible? Because we are not using the previous value. That's where we can update the values in the same array. Okay. So is it the best practice? Maybe no, but for this problem, it is relevant because we are directly modifying our original nums array here, right? So normally, when we implement things in our real-time application, we normally don't tend to modify the original given data. So that's where it is not really recommended when you try to modify the original data. But in this case, it is relevant. So you can explain it to the interviewer so that he will be happy by hearing all these points whenever you consider implementing optimal solution. So now with that, let us see how we can do. So n will be nums dot length. Okay. Now I will start from I equal to 1. I will iterate until n minus 1. Now I will simply say nums of I equal to nums of I plus nums of I minus 1. This is simple. I will simply return my nums array. This is pretty much straightforward. Okay, let us switch and let us try to. Now for the same thing, I will remove this part because we don't need extra array. I will remove this initialization as well. With that, maybe what I will do, I will simply use nums. So basically nums of I equal to nums of I minus 1 plus nums of I. Okay. Then finally, I will return our nums. With this, let's try to run and see. So it got accepted and I will submit this. If you see, it got submitted successfully. So this is the best solution because if you see the time complexity, it is of order n. It gets processed in only single iteration. If you see the space complexity, we are not using anything extra. That's where the improvement happened. So its space complexity is of order 1. Okay. So with this, now in this problem, we are getting introduced to this particular concept called prefix sum. So prefix sum. So why it is so important to understand this prefix sum? Because if you have seen, originally it was O of n square solution, right? And there was no need to process all the elements at all the iterations. So what we did, we tried to store the previously calculated value somewhere in the array. Correct, right? That's where the concept of prefix sum comes into picture. And using this particular way, so we will solve so many multiple problems in the upcoming videos. With that, hopefully you liked this explanation. If that is the case, please consider subscribing to my channel and also like the video, share this with your friends. And if you have anything you want to ask, you can add that as a comment. And also if you have understood it well, please add that as a comment as well. Thanks for watching the video.